Hey everyone, and welcome to this video on solving simultaneous equations. In today's video we're focusing solely on how we solve simultaneous equations involving a linear and nonlinear equation. First, we must be able to identify when an equation is linear versus when it is nonlinear. And here I have two examples of systems of equations where one contains a linear equation and a nonlinear equation. So let's take a closer look at the two systems that we have here, and we're going to be able to identify the linear equations and learn what are the distinguishing characteristics of nonlinear equations so that we will be able to identify whenever we're working with a system consisting of linear and nonlinear equations. In our first system, we have y is equal to 2x plus 3. This, if we can recall, the general straight line equation y is equal to mx plus c, this falls into the category of straight line equations simply because it follows that form of y is equal to mx plus c. Now, what about this second equation? Here we have xy is equal to 5. And whenever we see equations where there's a product of two or more variables, know that you are looking at a nonlinear equation. This particular equation does not follow that form that we just discussed, which is the form y is equal to mx plus c. So when we look at a system of linear equations, we can tell whether or not it's linear if the equation follows this form, as well as another form, y is equal to mx. So here we can clearly identify our first equation as a linear equation, as it falls under the category of the lines y is equal to mx plus c. And our second equation we can identify as a nonlinear equation, as it does not fall under either one of the two categories that we've discussed as linear equations. Now let's take a look at our second system. And when we look at our second system, the very first equation should jump out at us as nonlinear, simply because when we look at it, we notice we have the variable x raised to the power of 2. And this should call to mind the quadratic collection of functions, because whenever we see a variable being raised to the power of 2, immediately we should think of quadratics. So here I am dealing with a quadratic expression. This equation, y is equal to 2x squared plus 1, is a quadratic equation, and the second equation is linear. So here again, we have the linear equation, and in this case, our first equation was our nonlinear equation. As I mentioned, the nonlinear equation in this case followed the general quadratic form, which is ax squared plus bx plus c. So here's one of those very distinguishable nonlinear equations called the quadratic, and once we can recognize the quadratic, we can definitely classify it as a nonlinear equation. Now, the quadratics don't only come in this form. We know that we can also have quadratics which look like this, where we just deal with a squared variable. And we also know that we can get the full quadratic. So there are some systems that we might interact with where you'll see a full quadratic equation as part of the system. So now that you know how to distinguish between linear and nonlinear equations, we're going to take a look at a couple systems to see whether or not we can solve them. And specifically, we're going to look at the process involved in solving a system of equations where there is one nonlinear equation.